2/3 of the people at a fair wore hats. 1/6 of those who wore hats were men and the rest were women. There were 124 more women than men who wore hats at the fair. And we're asked how many people did not wear hats and how many people were there at the fair altogether. Okay, so we're going to draw a big bar for all of the people. We could label that people. There we go. And we're going to have this big bar. This is all the people at the fair. And in fact, I'm going to label that because that's actually one of my questions. So okay, and that's, I'm going to put a nice question mark there just to remind me. And what are we told? Well, 2/3 of the people at the fair, so that's all of these, 2/3 wore hats. So I'm going to split this bar into thirds. Okay, and we're told that 2/3 wore hats. Okay, so which of course means that if we've only got, you either wear a hat or you don't wear a hat, that must mean that this section are the people who did not have a hat, no hat. This is 1/3 did not have a hat. Okay, we've captured that information. Then we're told that 1/6 of those who wore hats were men and the rest were women. So remember, I've said when you've got a fraction, it's not just enough to pay attention to the denominator and the numerator. We also need to know what this is a fraction of. What is the whole? And this is 1/6 of those who wore hats. So this is what that is referring to. And in fact, I'm going to just draw, just so that we're clear, I'm going to put another color around this. Okay. Now, so far, this part, the people who wore hats, is split into 2 equal parts. That's halves. Okay. But I want it split into 6 equal parts, into sixths. How do I turn halves? Let's say I'm talking about 1/2. How would I turn 1/2 into sixths? I want sixths. Well, 2 multiplied by 3 gives me 6. I'd have to do the same up here. All right. And 1 times 3 is 3. All right. So you can tell if I can split these, each of these halves into 3. Okay, I'm going to end up with 6 altogether. 1, 2, 3, 4, 5, 6. This is, we're talking equivalent fractions here, aren't we? Okay, so 1/6 of those who wore hats were men and the rest women. Okay, so this is men. Okay, and then the rest were women. So I'm going to just put that in here. Okay, so I've captured that bit of information there. Right, this is where it gets potentially tricky if you're not careful. It says there were 124 more women than men who wore hats at the fair. So now here we are comparing, aren't we? And we've got this 124 more. This is a difference. And normally when we draw a bar model where we're told that something has more or less than something else, we wouldn't draw just one long bar model like this. We would draw what we call a comparison model, wouldn't we? Because it makes it easier to see. Now, you might realize that the men have 1 part and the women have 5 parts. So you could do, okay, the men have 1 part and the women 5 parts. Okay, and that the difference between 1 and 5, okay, so we do 5 take away 1 equals 4, which is the difference. And this is that, so that women have 4 parts more than the men, okay, and and it's the 4 parts equal 124. But that might just be, it might just be a bit tricky. You've got to think about it. So, of course, there's nothing to stop you from drawing another model. Okay, so you could then think, okay, I'm going to just quickly model this. I've got men and I've got women. How many parts do the men have? That's 1. How many parts do the women have? Well, that's 5 of these altogether. So 1, 2, 3, 4, 5. Okay, this is the same. What are we told? There are 124 more women. Okay, so I know that the difference between the two is 124. And that difference, and now you can very easily see it, that relates to 4 parts. Okay, so that for me is the only tricky bit. It's to whether you realize that this is the difference, because you might make the mistake of saying that the 5 parts are equal to the 124. Okay, so here I can see 124 is equal to 4 parts. So if I do 124, if I divide that by 4, I'm going to get the value of each of those parts, which is 31. So each of these parts has a value of 31, okay, all of them. And I can transfer that to my model here, can't I? This is just where I redrew so that I could compare. So this is 31. These are all 31. Okay, right. Well, what are we asked? We are asked how many people did not wear hats. Okay, so this is, I haven't put that in, no hats. That's one of my questions. And how many people there were at the fair altogether. Right, well, no hats. Well, what I should have done earlier is, because I split these up into 6, I really should have split this up as well, shouldn't I? The eagle-eyed among you would have noticed that, because this, remember, this part, it was just the same as these. So these each have 31. So if I do 31 times 3, I get 93, and that's going to tell me how many people did not wear a hat. That's 93. So each of these original thirds has a value of 93. Okay, so what can I do? I want to find out how many people there are altogether. I can do 93 times 3. Okay, and if I do that, I am going to get 279. Now, I also could have done it a different way. Said I just knew, I can see that I have got these 3 blocks of 93, but you also might have just gone, well, I know that I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 units of, or 9 parts of 31. So 9 times 31, and that just would have given you the same answer. Okay. All right. There's often going to be several ways that you can calculate, as long as you just keep track of what you are doing. And that's then our answer. Okay. 279.